Hi everyone, welcome back to another video. We're looking at alkane organic chemistry. So alkanes, let's just pick blue. So we can do this here. Okay. So alkanes, right? These are your halogens with alkanes, right? So this is a combination, right? And halogens in this case, these are our substituents. We've already defined what substituents are. So this makes it easier for us. So that's why we had to define what substituent are and what the parent chain is, right? So these are our substituents, right? And these are our alkanes. That is the part of the last part of the alkanes. That's your parent chain, right? So halogens, as we've discussed in the last video, these are group 7 elements, right? Yeah, this was meant to write elements. So these elements with a valency electron of one, right? So that means they can only form one bond, right? So the functional group of alkanes, so this will be your alkanes with halogen substituents, right? So this will be C and an X at the end there. So that X could be at the top, this side to this side, right? That's just a functional group. So you see this one, oh, those are halogens, right? So that's the point of a functional group. And it also shows that this is a different organic compound compared to alkanes or other hydrocarbons that we have looked at before, right? So the naming of the halogens goes like this, right? So you have a prefix. The prefix now is your halogen, right? If you have chlorine, that will be what? That will be fluoro, right? So that will be a chlorine, and that will be a fluorine, right? And then this is bromo for what? For bromine, and then this is iodo for iodide, right? So that will be a prefix. You start with that one, but you have to specify where the halogen is, right? So you will include the location. If it's on the first carbon atom, you will say 1x. And then your X, this will be your chlorine or your fluoro, your bromine or your iodide, right? So let's say it was what? It was bromine, right? So that will be what? It will be something like one bromine. So this means that your bromine element is on the first carbon. It could be two, could be three, could be four, right? So that just shows the location, right? So that's how you name them. And then at the end, the suffix that will come, that will be your parent chain, right? So for example, let's just try to name this one example one. So example one, we can name it as, okay, this is what the main chain, what is it called? It's propane. It has three carbon atoms. Prop, it's an alkane, propane, right? So that is propane. Okay, we have identified our main chain or main molecule. Okay, where is the substitute and what is it? It's a halogen, it's bromine on the second carbon atom. So it will be 2 dash bromo propane, right? So that's how you write it, right? So that's our naming, right? So that's our name of the first one. So the second one now, what is the main parent? So you have one, two, three, four. We already know it's bute, right? Because you have four carbon atoms and alkane, so it's butane, right? And then where are your halogens? You have the first one there, and then the second one here, bromine, chlorine. So where is it? It'll be one because that's on the first carbon atom, bromo, but you have another one, right? So this is for case where you have more than one halogens, right? So that one will be what? That it's on the third carbon. So that will be three chloro uh butane. All right, so that's the name. You see, when you look at the name, without understanding what's happening, you may think, oh, that's a little bit complex, right? But it's not, right? You take it step by step, right? To the rules, to those, to the naming of these organic compounds, right? So bit by bit, you understand how to name alkanes, alkynes, and then you get to understand how to name substituents. When you have a substituent in a place where you are supposed to have an H. Oh, but if you don't have an H there, right? So it will be different. So if for example, between these two, instead of having an alkane, oh sorry, we can't do that because these are haloalkanes, right? I wanted to put a double bond and see how can we name that one, right? But let's not make it complicated than it already is, right? But this is very simple for us because we've already explained how we name these ones. So the prefix will be what? Location of your halogen and the halogen, and then that will be for all of them. If you have more than three, if you have three, that will be location of halogen, halogen, location of halogen, halogen, location. Then it will go in when it will go in an ascending of the location, right? That's how it will be, and at the end you will have your parent chain, right? So that's how you name them. So let's just look at the general formula for your um, general formula for alkynes, right? So the general formula for alkynes goes like this. That will be CnH2n plus 1, and then you will have your X. So this is for your molecular formula, right? I'll use molecular formula supposed to be, right? What is it supposed to be? So for this one, it will be you have 4, right? So this C4H. So how many do you have? You have 3, and then you have 6, 8, right? That will be C4H8, and then you will have what? And then you have a problem now because you have more than two, right? So for this one, the it will be a special case, right? So it will be more like a condensed formula. So it will be CH2 pray, right? I think that's how we write it. But I'll actually confirm this, and then we'll look at it when we look at many examples on how you can write the condensed formula of alkanes, right? But so we just look at the simple one, the first one. Um, see. Okay, so the first one, so let's say you have three, right? The one we only have one one, what is this? One halogen, right? So this will be H what? Three and then 6, 7, right? So you have 7 and then you will have your BR at the end, right? So it says that this one is 2n plus 1, right? Is it? Yes, 2, that will be 6, and then 1, that will be a 7. So the general formula works, right? Even in this case, the general formula will still work, right? It actually wouldn't still work because instead of you having it's disrupting the what is this the formula because it only accounts for one halogen. So this one won't be able to work. For example, because this will have to be a 5, right? And then you have what? Let's see. So you will have 10 and 11, but let's count them. 2, 3, 5, 7. Okay. 2, 4, 6, 7, 8. You have 8. You only have 8, right? Is that okay? Oh yeah, this will be 4. I mean, this will be 4. So this will be 4. So that was supposed to be 9, but you only have 8 because the H here was replaced by another halogen, right? So that's the problem. It's disrupting the formula. So it only accounts for what? For when you have one halogen, but we'll look at the case where it occur where you have two and what do we do, right? So I'll check that one out for you. But this is halogens and this is a crash course for halogens, for you to actually understand what halogens are, how do you name them, and also what is their general formula, right? When you only have one halogen, right? So just play around this, try to understand. If you understand the naming, you understand the structures, the molecular structure, and also we'll look at the condensed structure on the next video, right? Thank you very much. Bye.